starting with first technical lecture, and the topic which was given to me was on, you can see, efficient energy utilization for smart renewable energy based irrigation system. So I will be covering the context of agriculture, particularly irrigation, uh, and then what is the renewable energy options are there with us in terms of meeting that irrigation demand of the agriculture. And then I will be covering the policy framework. There are very large program which is happening currently under the name called Kusum program, which is a central government program across pan India to address irrigation energy requirement through renewable sources, and primarily uh, I would say solar energy. And this is a very large program which is happening, and some development also happening in Jammu and Kashmir, that detail, and what kind of a technology options are there in that program, that I will be explaining you. And for that system, because this is an entrepreneur based training program, skill development, what kind of a SOP are required to operate such kind of a system which is new in agriculture practices. Then in last, I will be sharing with you towards the end of my presentation the case studies across different states which are more innovative in this program. So couple of states case study I will be presenting you on, just to conclude the presentation from my side. So my name is Sunil Dhingra. I was associate director with Terry for 35 years, and now I have an independent company called Biotrain Energy, which is working with farmers on two aspects. One is to meeting their energy requirements, making more like a, I would say, converting their stubble into biofuels. And biofuels, when we say that, it can be converted into solid, liquid, gaseous form. And so, but that is not a topic today. So, but later on we can discuss that. So, if why we are talking about renewables, why we are talking about, because our climate is under threat. So, this is the statement just to give you, the era of global warming is over. It is now global boiling. So, warming is a physical state, and boiling is really a serious challenge now on the environment side. And every part of the world is facing this problem in a different fashion. Just to give you example, very recently in Spain, there was a flood, and there are some cities have completely wiped out. There were no single drop of water in that region. Why? It was on 25-kilometer away. There was a heavy rain, and the water system, the huge water, carried away the whole city by surprise. And that is part of the climate change. So it's a serious threat to all of us. So globally, and recently the COP29 is happening, where all countries are committed to make their uh, countries net zero by, some countries will do by 2050. India has committed to 2070. So that means whatever emissions we are emitting across different sector, including agriculture, household, industry, transport, that has to be decarbonized into renewable forms of energy, or something which is more sustainable. So that is the framework will happen in, and so, but we will focus on the sector which is agriculture. and that too irrigation as sector. So just to give you the context of whatever we are discussing. So I have to let me because I. So if you see that the challenge, energy and agriculture. Agriculture is an energy intensive process with significant process of energy in irrigation is required. And as our groundwater is going down, that means more energy is required to lift that water to the for the agriculture application. So that means more and more irrigation needs, and India is agriculture intensive country, and um our reliance on irrigation is largely on diesel and grid electricity currently, and that has to be phased out to renewable form of energy, which we will be discussing today. So challenge in traditional energy, high energy consumption, high cost, and most of the agriculture energy cost is subsidized by many state governments. Whether you talk about Punjab, whether you talk about any other states, and agriculture is subsidized from the input energy point of view. So, but that cost somebody has bearing in terms of, and it is bringing inefficiency in the system also. Because if anything which is given free to me, I will not value that because it is free. It is somebody else paying that. So inefficiency is part of the whole mechanism as such. So this has to be get addressed. Our dependence on fossil fuel is high. So diesel pumps which are running, our dependency of diesel in the country is import. Almost 80 to 90% of our fossil fuel are imported in the country. We are not producing that to that scale. So energy security is limited. So and we are emitting a lot of carbon, CO2. And because of this nature, the water wastage is there in terms of inefficiency, which is there. So address is that solar energy and other renewable energy, which is sustainable alternate to conventional energy forms. So that is the drive for renewable energy to come in for agriculture application. So if one look at the renewable energy development in India, so this is the slide. You can see that on the top that our installed capacity number, where most of the power which in the grid we are using, like this all that whatever we are seeing, 46.8% is coal. India is still coal dependent country, so our electricity is still not decarbonized. And but our renewable energy share is increasing. In the installed capacity right now, 33% is renewable which is coming. And if you see the share of renewable, it is coming from wind power, solar power, small hydro, biomass, waste to power and waste to energy, and these are the actual number installed capacity of renewable energy which is there in the country. So if one look at renewable energy with large hydro, large scale hydro, then we are about 45% mix coming from the renewable energy side. And if we see without large hydro, then it is 34%. Just giving you the context of what we will, and we will come specifically to uh, and some of the slide I will skip. So this is the progress. As you can see, the graph is continuously increasing because of the push of renewable energy. As you can see from 2010 till 2024 data, it is progressively increasing. All forms of energy, as you can see, and particularly uh, solar energy, for example, where from this 2016 onward, the share of solar energy is exponentially increasing. Okay. So now this is one dimension of renewable energy. The second dimension is the GHG emissions. So if one look at the Indian GHG emissions sector wise, energy emissions are almost 76%, because as we can see that most of the almost 46% is coming from coal, which is emitting a lot of emission in the atmosphere. The second largest is the agriculture. 420 metric ton of CO2 equivalent is coming because of the agriculture activity, which is 13% of the total GHG emission of the country. Large share of coming, and the other one is the waste and this uh, land use application. Now, if you look at from the agriculture side of the story now, so India has a total land area of about agricultural land area of about 328.7 million hectare land area. Uh, Area under agriculture, and our fresh water requirement, all that. So now look at this slide. Agriculture pumps, electricity grid connected pumps are 22 millions, which are running on the grid side of the story, and most of them are actually subsidized from the electricity side. So Discom is paying that. Then there is a diesel pump set, which is about 7 million pump sets are there, and the total subsidy of about 1000 crore is spent by various government on the electricity side of the pumps. Uh, if one look at the energy consumed in agriculture, all India level, this is the number, and the share of electricity in total grid electricity is 19% at the pan India level. So out of 100 units which is there in the grid, 20% is consumed in the agriculture side sector. Rest is for household, commercial, industry, all that kind of a thing. So large chunk of electricity consumption is there uh, uh, for the agriculture application. Now specific to J&K, Jammu and Kashmir, this is a 2022 and 23 data. The total uh, consumption is about 358 gigawatt hours, and which is in the agriculture, the share is 3.6%, because it is not agriculture intensive state as such. So only 3.6% of the electricity in the grid is utilized for agriculture. But in pan India, where states like Punjab, Haryana, which are largely agrarian society, there the percentage is very, very high. So this is the distribution on the pan India basis, the sector wise, the pie chart that you can review that later. So there is, to address this challenge of energy and climate, Government of India has promoting energy efficient irrigation practices in agriculture, and this program is called Kisan Urja Suraksha Evam Uthan Mahabhiyan. So it is called PM Kusum program. Is a government initiative launched by MNRE, which is Ministry of New and Renewable Energy, to empower farmers by meeting their energy needs, suitable and promoting eco-friendly agriculture practices. So many of you who want to become an entrepreneur later on, this is a good opportunity under the program. You can scale up through this scheme in your businesses wherever you want to you do that. So objective of this PM Kusum program: water security, utilization of degraded and unutilized land for farmers. So where grid is not there, for example, then you can set up this, and degraded land can be irrigated through solar pumps. Additional income to farmer by selling surplus power to the grid. So now the uh, they can become urja data. They can also sell electricity apart from the agriculture. They can from the solar power, and we will study that how they will do that. There is whatever surplus power generated out of the solar, they can sell it to the grid, because not all the time pumping requirement is there. But this solar power plant will produce power on a almost daily basis, continuous basis, on a daily basis whenever there is a sunlight in that. And but all days your pumping is not required, the irrigation is not required. So that power you can sell it to the grid. So that means that's an additional income for the farmer. So objective is so promotion of decentralized solar power system, water conservation, and indirectly this will save burden on subsidy. As I told you that about 1,000 crore subsidy is been provided by subsidizing the grid in by electricity department. Excuse me, sir. Yeah, please. So basically, as you are talking of Kashmir, the discom is not in a condition that they are not currently buying the surplus power from whether it be solar grid connected rooftops or these pumps. They are not in a condition. So how we can address that? So because they are not currently buying; they are only exchanging, but they have non-availability whenever. So because the to be very frank with you, power is a co-current objective. So it has central government and state government has equal control of that this thing. So innovative policy framework has to come in. So some states have very progressively pushing the solar power in their state by innovative this thing, tariff system, investments, and all that kind of a thing. So through policy initiative, you have to do it in state like JNK. I specifically don't know the issue, to be very frank, but you have to create, uh, I would say, policy paper, because government agencies also have to be educated on this subject, and they are open, but one has to uh, work with those institutions. I don't know very specifically the discom are not buying or there is no attractive. So let's look at the examples and work around that through institutions who are working here. That's a advice from my side. So coming to now the PM Kusum scheme, there are three components. It is called component A, component B, and component C. Component A talk about grid connected solar power plants at the tail end of the grid. So at the tail end of the grid, the reliability is limited, availability is limited. So the whole idea is you identify the tail end grid in the rural areas where you can set up these power plants and supply it to the grid. It has nothing to do with irrigation. It has nothing to do with grid irrigation. So this is component A. Component B is off-grid pumps. So installation of this is wrong. That it is 20 lakh standalone solar power agriculture pump sets. So that's the target. 2 million um, standalone solar power pumps is the target. Component C is individual pump solarization and a feeder level solarization grid connected. So here what we are talking about is when I don't need for pumping, I can sell it to the grid. So these are grid connecting, the component C. Component B is off grid. So that is only for irrigating the land. That's all. So like wherever diesel pump sets are there, they can be offset by component B. And when you are on the grid, then the component C is there, which is grid connected pumps. So differentiation is like this in the scheme. Huge targets to fulfill uh, in coming years. So this is what we have discussed, that standalone solar agriculture pump designed for use in the off-grid area where electricity rely on solar photovoltaic panel to generate electricity, which is then used to operate water pump for agriculture irrigation. And the key feature is individual farmer in the off-grid region. Purpose is irrigation and agriculture. Up to 7.5 HP pumps are allowed here. You can install bigger pump also, but the subsidy will be limited to 7.5. So that's the ceiling. And subsidies varying to the based on the region and the benchmark cost of so we will I will give you those number later on. Um, so under this component B, as you can say, individual farmers, water user association, FPOs, primary agriculture credit societies, community cluster, they are all eligible for this program to as a beneficiary. Applicable state, North Indian state, Himachal, Uttarakhand, J&K, Ladakh, all states are applicable here. Central finance assistance up to 50% is provided, and state has to contribute 30% assistance. So almost 80% of the cost is subsidized by state government and central government in this case, and farmer has to contribute 20% in this program. And so this is the pump capacity which has been defined, and solar module capacity minimum is 300 watt. Or now module size is 400, 500 also. I think something is not coming. Not showing. I think his text is missing. Okay, we'll leave it with this. So typically, how it no, can you go back? Okay, we will see this. So solar radiation to a solar panel generating power, and then there is a pump controller, and then pump controller will drive this pump uh, for irrigation, both some surface pump or submersible pump. So this is anyway we have covered in the previous slide also. If I can skip this. So component B benefits are reliable source of irrigation to farmers, saving of diesel cost, increase farmers' income, option to connect to the grid in future wherever grid is available, no additional electrical load for agriculture pump, and de dieselization. So we will be moving away from the diesel consumption. As we have seen, there are 1 crore pumps which are on diesel as such, and so we'll save foreign exchange at a national level. Now coming to component C, to solarize, so this target has increased to 20 lakh agricultural electricity consumption through individual pumps up to 7.5, as well as through feeder level water conservation and extra income for. So there are two parts. One is the individual pump solarization, where a single farmer can adopt this, or feeder level solarization. So many states have a different agriculture feeder now. which are not connected with other consumers, like for example Gujarat, for example. So they have segregated the lines. Agriculture is different, and your other feeder is different. So this feeder level solarization, so complete feeder can be solarized, agriculture feeders, through this scheme. So which means there is a large capacity solar power plants which can be installed at a common place, and all the pumps on the feeder can be solarized. So here is a community or the discom owned facility. Here it is a individual farmers. So the but both schemes are covered under this program. So as you can see that installation of solar panel, direct pump operation, extra power export to the grid, and the farmer is typically responsible for upkeeping and the minor maintenance of solar panels, though there may be a periodic the inspection by authorities and the government agencies. So wherever there is a common facility, that being taken care by discom in this case. So the working principle here is you have a centralized solar power plant installation, a large solar power established at the feeder level. The plant generates enough electricity to power all pumps connected to the particular feeder. All pumps in the feeder will be get connected. Direct grid integration. Solar energy produced by the central plant is injected to the local electricity distribution grid, where it powers to all the agriculture pump connected to the feeder. Grid monitoring and control system. Discom manage power from the centralized. So ultimately, it's a Discom who is responsible for that the facility. Centralized solar power meter ensures stable electricity from agriculture pumps, allowing farmer to use grid electricity, supplementing or fully provided by solar power. And maintenance is generally done here in these cases by Discom, because it's a central facility. So individual farmer need not have to worry about, or a third party, or maybe vendor who has set up this facility. So the key difference between individual pumps solarization and the feeder level pumps is the scale. So small scale, this individual pumps are small scale. Here it can be a large one. It can be say 50, 100 kilowatt kind of a feeder level program. uh, Solar panels installed in the individual farmer. Here it is centralized one. It is managed by individual farmer. It is managed by Discom. Directly power individual pumps. Excess sent to the grid. Here it is feed solar power into the grid to all power all the pumps on the feeder. It is net metering. Land required in this case is land near the pump, whereas no land required from the individual farmer in the solarization system. Ideal for isolation farms in the first case, cost effective for region with high pump density. If a if you have large small scale pumps in a close proximity, then grid feeder level grid electrification is better. Active role by farmers in these case, it is a passive role, because he is just looking mostly agriculture as activity in this case. So the whole idea is that Discom will save recurring deficit by low agriculture tariff. It's as I told you that most of the, and you will see the case studies also later, most of the states have given subsidized grid tariff for agriculture. So that burden is there on the state budget. And many states are now bankrupt in their finance, because farmers are being subsidized in most of the this there are like Punjab, for example, or Andhra Pradesh, where intensive agriculture is happening. Farmer will receive reliable daytime power, Farmer can sell extra power, extra money to them. Farmer will be incentivized to conserve energy as well as groundwater in this case. No additional electrical load to the grid. So there are positive to all stakeholders, whether it's government, electricity supplying company, farmers, everybody can gain out of this. But the challenge is behavior change. As I told you, if something I am getting for years free, changing that mindset is not that easy. Being a human being, whatever good to the environment, whatever good to this thing, I want to enjoy that. That's the mindset. So it's a slow process, and so that's a barrier, social barrier. When you adopt these schemes, like you said that very correctly, even state government are not willing to adopt innovative solution because either they will miss some control out of the system or something is missing in their thought process. So this is again very similar what kind of a cost benefit saving to what we are developer, discom, central government, everybody is saving part of the pie through this program. So one look at from target we have seen now what is we have achieved so far. So if you look at that component A, which is not the what we are discussing today, so out of the total sanctioned 9,110 megawatt of total sanctioned project, and this is a data of September 2024, 298 has been implemented. Still long way. You see that it is hardly any percentage we have achieved. Uh, and if you look at from the component B, 13 million pumps have been sanctioned, 13 lakh 42,000 precisely, 1.3 million, sorry, and only 5 lakh pumps have been installed so far. So again, a big chunk of that has to happen uh, in the implementation. In a component C, as you can see on the individual level, and the second one is the feeder level, the number and achievement is very small as we speak. So long way to go in this number to achieve. These are pan India numbers. Now these are the numbers specific to JNK. As you can see, there is no target for under component A in JNK. Component B, the total standalone pump installed is 2,000, and in component C, there is nothing as we are talking about. And district wise, the pumps, standalone pumps installed are this: Anantnag, Poonch. You can see you are more familiar with these districts. So as you can see, Anantnag has maximum number of pumps. Then Kathua, uh, then of course other districts. Yeah. So this is the total list of 2,165 pumps installed in the state. As far as the target is concerned for JNK, uh, Jhakareda, who is the state implementing agency, 5,000 are sanctioned, and in component C, 4,000 has been given to the state, and nothing has been achieved in component C so far. So this is an opportunity for maybe many of you, depending upon what strength you have, what type of interest you have in this. So there is a clear case of entrepreneurship which has to come in this kind of a business opportunity. And remember that because these facilities are to be operate and manage for the lifetime. Lifetime in the sense that, say, 20-25 years during the lifetime of the equipment. So service support, maintenance, all that is part of the entrepreneurship. And you will not only learn through this scheme, but there are opportunities like floating solar, for example. So I was involved in one of the project in we are discussing with DST on floating solar projects in Dal Lake, for example. You have such a high water body, and some part of that can be utilized for uh, floating solar projects, which can meet some of the requirements. But the challenge here is the weather conditions, the temperatures. So floater during winter will get freezed. So we are working on a project with CPET they are designing uh, plastic floaters which can sustain those temperatures. So these are some of the work you can extend from this scheme to other application or rooftop solar. Other day we are talking about uh, opportunity of agrivoltaic, like you have uh, 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 agriculture on the surface, and on the silt you have roof solar panels. So that those kind of a opportunity one can look at beyond this scheme itself. So these are a standard component of a solar pump component. One is there are five broad component. One is the solar photovoltaic panels, solar pump controller, pump motor, water storage system, which is optional, or you can just directly feed into your land area, or inverter if it is required. Is a DC or AC that if you required AC pump to be operated, then inverter is required. DC it can be directly fed into without inverter. So this is the typical solar panel feeding to the controller, then controller to borewell, the bore pump, and then outlet pipe to the water tank, which is optional in this case. So this is the schematic for as you can see that uh, there are two type of pump, and the delivery head is different. Here it is a surface a ground level pump. The suction head is there and the delivery head is there. The total head is suction plus delivery head to be maintained by the pump. And here it is a submersible pump where delivery head is where you are feeding to uh, the surface. So now looking at what is the SOP, standard operating practices, because you are now entrepreneur, or you want to bring the skill. So if you have to set up this, what kind of a technical SOP you have to. So some of these slides I'll be sharing with you. So one is the site selection. You just can't put at any given point of time, because some assessment has to happen at that site. So evaluate that the pump solar control placement. So you have to visualize as an entrepreneur that this which is the best location in that particular geography or that particular farm where I can set up more effectively the pump. So that site selection is critical important for this thing. And estimate energy potential, how much energy you can produce out of that location. Then accordingly you will design your solar panel and the structure. which is required to meet the site requirement. So clear and level installation area where you will install that solar panels. Panel facing south where the maximum radiation will be there with no shading, 30% tilt to the optimal generation that has to happen. Uh, uh, then these are other parameters which you have to take into consideration. For example, what kind of a spacing you have to require between these panels. Uh, module uh, module with nuts and bolt. What kind of a nuts and bolts are required to be placed, and very importantly is when you do structure installation, the spring washer has to be part of the connection because that will give the proper engineering installation. Many times we miss those small things which will affect the overall operation. And the structure has to be rigid, avoid mechanical stresses in the system. In pumps, for example, ensure leak-proof plumbing. Plumbing is very critical, and you will depend upon local plumber in terms of the bend size, in terms of everything. So leak-proof plumbing is critical. Surface pump in ventilated house, space for plumbing because access has to be there. In case tomorrow you have to give service, accessibility to that location has to be there. Submersible pump secured with stray void and unions above pump for easy maintenance. So union is basically where you can dismantle. So tomorrow there's some pumps to be maintained or some service is required. So you can dismantle that through this union. That only part. Proper insulation of all electrical connection is critical important during the installation of solar pumps. So, and pump controller, very importantly, is housed in a protective area where and it has to be labeled box against rain and dirt because this is electronics part. Water, moisture will affect its operation, and it has to be clean from the dust perspective. Cable, use conduit cable. uh, so secured cable, its cable should not be loose. It has to be stick to the panel all the time. It just can't be loose wires around because then maintainability will be very difficult. uh, Float switch, contact switch that prevents pump dry run by stopping it when water is low. So for example, your pump is on and water is not there, so it will affect the operation, its pump efficiency, and it can burn out the motor winding, for example, overheating of that. So that has to be protected in true sense. Protect pump from overheating and damage. So that is there. And of course, ground pits. Locate ground pits near panel structure with low soil resistivity. Ensure ground resistance at 10 ohms or less. So these are some of important, I would say, engineering practices one has to take care while installation of solar pumps for his better efficient operation. Now coming to, now installation is done. Now the operation and maintenance. Now the facility is installed and all the standard operating practices what you have learned is being practiced on ground. Now the operation and maintenance of the solar pumps. One has to look at solar photovoltaic array panel cleanliness because it can affect the efficiency of my generation if panels are not clean. prevent soiling losses and maintain efficiency. Because if dust is there on that, that means my output will be less. When output will be less, that whole efficiency or effectiveness of the system is lost. Panel condition replacement, damaged panel has to be there. Sometime what happen is some of the panel get destroyed. So you have to identify the panel which are non-functional and that need repair. That has to be changed. Proper insulation, secure terminals and routing. Earth connections are important factors in operation, during operation. Check water discharge, head temperature, input power. Ensure earthing connection are secured in the pump to know the efficiency of the operation. In a controller box, ensure junction box is firmly attached with screw. Avoid loose cables wherever it is there. Over a period of time, we see in our homes also some of the connection get loose. So that needs all the time some tightness, changing or whatever is required there. Uh, uh, Connection must be corrosion free and secure. Sometime because it is in open, there are a lot of rain, so some corrosive effect will maybe there, that need to be changed. Cable insulate terminals and cable properly. Water seal and controller to pump cable. Check connection for corrosion and tightness. Keep cable paths dry to keep prevent short circuits. So no short circuit should happen because of the moisture in the electrical side. So all that during the operation one has to look into during the operation of the plant. Some are regular kind of a maintenance requirement, some are weekly, some are monthly kind of operation. And when you keep monitoring the output from your power plant, you will come to know my uh, pump is running on a design capacity or not. From the performance data, you will come to know if it is not running to the design data and with very less efficiency, then you have to find out the reasons. And these are the typical reasons for is low efficiency. It could be solar panels got not clean, because of which the generation is limited. So all that has to be part and parcel of the work. Then some of the important issues and how you have to resolve that. So typically troubleshooting, uh, type A, one type of is the fuses and MCBs are non-functional or it got disconnected. So troubleshooting is disconnect the PV array, check fuses and circuit breakers. Many times in home also, because of overheating or in some situation that happens. So first thing is to look at the fuse are correctly placed or not before starting anything. And for to do that, you have to circuit has to be disconnected to check the fuse is working properly, loose connection, burnt spot, etc. That has to be find out. Then second is fault panel or wiring, maybe some disconnection from PV array and check the array against radiation level. Uh, because what happens is non-sunny day output will be low. So radiation level and voltage, output voltage has to be corrected all the time. Because if radiation is not there, voltage will not be there for obvious reason. So, but if radiation is there, output voltage need to be correct. If voltage is off, inspect panel wiring, because that means output is not coming from the wire which is connecting the solar panel. Low current may indicate loose, corroded connections or damaged panels. If my current is not proper, so these are some of the factors which need to be corrected. And corrective action, as we can see, disconnect all panels and check them individually, replace panel that are not working, uh, clean all terminals and cables, make sure the panel are clean and shade free. Sometimes there is a shade in because of the tree or building or any other reason that need to be corrected. Verify the voltage output of the array is as designed. Issue related to now the pump side. Uh, uh, so that the other issue can come is the controller. So my faulty controller is there. So my array, the first level we have checked, the fuses we have checked, we have seen the panel, that is all correct. Now the next level of fault can come is faulty controller, the second the system, the one which is there. So check the fault indicators and codes, measure DC voltage in terms of voltage output and voltage at the input and the output sides. Ensure voltage correlate with radiation. As I told you, always remember voltage is directly linked to the radiation. If my radiation is low, my voltage also will be low. If my radiation is good on that day, output voltage has to be of that level. So that is and then compare input and output power, measure voltage, current, and calculate power. Check input parameter, pump capacity, voltage, current, and array size. Corrective action in these cases, diagnose the fault indicated by referring to the controller manual. So now there is a manual which is given to you by the company who has given you the controller. So there is a detailed manual do's and don'ts and the faulty condition that you have to look into that. Ensure all input parameters are correct while you are measuring. Replace the controller if the deemed damage. In case the controller is not proper or damaged, so that means my line this need to be get replaced. So that is the second level of connection checking. One is the solar array, PV array. I have checked, and now controller. Now assuming these two are okay, now I will go to the third level. Very simple. Otherwise, it's a two or three component only. But because these are in the field, in open, with no control of the ambience, and uh, 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 so something can happen all the time. So the third level is the solar irrigation pumps, faulty pump. Now pump can be, everything is okay. The first level, second level you have checked, third level you have checked. Now the last level is the pump, faulty pump. Ensure cable connection to the pump correct, waterproof and tight. And check there is no dirt in the pump inlet, because many times our water has lot of dirt which can block the inlet of the pump itself, and which many times happen that need some cleaning in the field. Inspect the impeller. Impeller is sometimes it's got jam. So irrespective of my solar PV is producing power, controller is working fine, but it is not able to produce that power because it is all jam. So pumping, it is not pumping the water. So that impeller need to be corrected. Check rotor rotates freely, lubrication freely. It is there. For submersible, check if rotor and impeller teeth are securely connected and corrosion free. So corrective action, impeller, maybe some cases impeller damage, replace the impeller in that case. If the rotor is jammed without debris, contact the supplier or manufacturer. OEM you have to connect. If the rotor and impeller connected teeth are corroded, replace the teeth after connecting the supplier or manufacturer. So these are some of the practices during the operation you have to look into. It has some mechanical parts, it has some electronics part, it has some controlling system. All that is an entrepreneur, good entrepreneur will able to address in that situation. So if you are become a master of that, you you are a good entrepreneur. You have technical skills, you have business skills, you have and this is a recurring kind of a business for you, because ultimately beyond a warranty period you will be charging to the beneficiary, whether it's a discom or individual farmers or whosoever. So so this is a good opportunity for you to become solar entrepreneur. And solar pump is incidentally we are discussing, but you can do business around other solar based devices. We have talked about solar rooftop, agrivoltaic, solar rooftop, solar pumps, solar everything can be run on solar in a decentralized manner. So this is just an example I'm sharing from the irrigation side of the story. So coming to irrigation pumps, the fourth level is the low intermittent water output. So my water coming out of the pump is low or not regular, not continuous. So in that case, the common issue is inadequate power generation, and it is could be from shading, damaged panel. Some of the panels are damaged. Uh, we have long panels, long cables. That means more resistance, more so that need to be avoided. Loose connection, incorrect panel direction, and sometime dirt on the panel because it is an outside level, so that need proper filling. Remove the cause of shading, align the array in the correct direction and tilt, replace any faulty panels, check for the voltage drop and power loss in the DC cable. In case the voltage drop is greater than 3%, either increase the cable size or decrease the length, so the resistance become low in my connection. So these are some of, I would say, good engineering standard operating practices for a solar plant to get operated. S- so when you clean the uh, solar panel, uh, use soft damp cloth. It should not be harsh because there will be degradation on the glass if it is not soft, and degradation losses are very high. If there is a scratches on the panel glass, it can reduce almost 3 to 4% drop in your generation. So it has to be very soft kind of a cloth. Cleaning has to happen, uh, and keep the controller dry and clean all the time. That is the requirements in typical operation and maintenance requirements or good engineering system. So this is do's and what is I am not supposed to do in my system, avoid cleaning the panel during daytime. You always use during non-solar hours the cleaning. Keep the panel shade free, and that is important when you look at the site assessment also. It has to be on the south facing, 30% tilt, and in open area, because otherwise your operating design efficiency will be low all the time. That you should avoid. Do not use water to clean any other parts except solar panels. Sometimes we have a practice that okay, there is a running water in the field, so use that water. So and that water can spill over to some of the electrical side of the equipment also. That we should avoid. Do not connect or disconnect any wires of the system without consultation with the qualified technician, because it has live connection also. So that need to be seen. Water source should be free from debris, because otherwise there will be damage to solar pump. So these are some are controllable, some are not controllable. To be very frank with you, because in field uh, when you have installed and this training you have to give to the farmer also. Ultimately, as a good entrepreneur, your beneficiary should be educated finally, because he is supposed to run the facility. So now coming to this standard operating practice, we have discussed on the installation and commissioning side, operation side. So cost of the solar pump as described in the tender document. So you can see this is the number I have collated. The pump size in HP, 1 HP, 2 HP, 3 HP, 5 HP, 7.5 and 10 HP. The difference is DC DC, submersible surface level, so this is how different cost structure is discovered in J&K tender, uh, which is the figure I have collated in the slide for you. And these are the vendor list in the tender, who is supplying this component B pumps. And some of the companies are Haryana, Delhi, Rajasthan, Delhi, Karnataka. So most of the pump supplier are from outside J&K, and we would like to see many of you become suppliers, whether under a licensing agreement or individually also. So, so there are a lot of opportunity, and still long way to go, because 5,000 target is there in the state, and 4,000 target for component C, which has not even started. So this is a typical Tata Power solar system uh, specification for DC surface pump, AC surface pump, DC submersible pump, and AC submersible pump. This is the typical size array they use for PV, and this is specific to J&K. Pump capacity, dynamic head for this, and water discharge liter per day, as you can see. Now, as I told you, these are my final set of slides specific to the business model in other states, which other states had adopted for solar pumping program. So, starting with Gujarat, for example. So, हाँ जी, ये ले लो. So, if one look at the first level is ACO is average cost of supply. Every state has, when they supply to different consumer set, household, industry, commercial, agriculture, but utility is one. So the average cost of supply is 6 rupees per kilowatt hour. The discom is supplying say 1 rupee to the agriculture, 10 rupees to the industry, 4 rupees to the household. So average is 6 rupees in Gujarat. So the similar case you have to find out in JNK. Agriculture tariff you can see is 0.6. That means I am 6 rupees I am spending, and I am also already only 10% I am charging from the agriculture. That means I am giving from my other pocket. So, and this is the case for all states, most of the states. Agriculture is the lowest tariff. That is how agriculture loads are critically important. And my average procurement price is in Gujarat is 3.5 rupees per kilowatt. So net metering model, the inverter capacity 1.2 times the HP motor, the pump size, PV capacity is 1.5, 1.1 times inverter capacity. Cost of solarization is something around 50,000, 50.295 per watt inverter capacity. And selection criteria is the feeder availability should be 90%, and 70% of the farmer in that grid should be agreed to solarization of the feeder. So this is the background number. Now, what it meant for farmers? Uh, Minimum 5% of the capex they have to spend in Gujarat. They will avoiding the electricity purchase, whatever that small amount 0.6 per kilowatt they have to spend, that is avoided. Income from excess generation after loan repayment is available to farmers now. Earlier they were paying 0.6 per kilowatt hour, now that is not there, and there is an additional income now because of the solarization of their feeder. State government is giving 30% subsidy uh, in their program. NABARD providing loan to this program. Uh, so there are two different categories of loan one, loan two. One can look at which one they, and discom power at a cheap rate, flat rate of 25 years they are paying to this. So loan is given at 6% interest rate, 7-year repayment cycle at this thing in this particular case. Andhra, uh, there the similar number you can see, the agricultural tariff there is zero. It is free. There it is 0.6. It is free electricity to the agriculture. So and through this scheme, state government avoiding subsidy provided to the agriculture. Discom 100% capex is installed, is given by the discom, and power at a cheaper price, flat rate of 25% in these cases. I'm just sharing with you the states which have taken proactive role in and because these are all agriculture intensive states in the country. Haryana again very similar, very low tariff, and cost of supply is 7.35 rupees. Large agriculture load in the state. So these are some of the number which is given. Rajasthan. I think some of you are from Rajasthan. You can look into these numbers. Maharashtra, as you can see. Uh, so one case study, I think So from the business model in the Gujarat is like this. So I have a solar pump, power available for irrigation to farmer in the cooperative. This is a cooperative, solar cooperative society, and additional revenue earned by farmer from the discom. Solar cooperative comprising of 6 farmer in this case with grid connected pumps, 3 pumps of 5 HP and 3 pump of 7.5 HP in this 6 farmers group, and power purchased by discom is the extra power 4.63 rupees per unit in this case. So how much they will the impact this scheme has done. So let's look at this number. So if you look at the last one, the each farmer will approximately earn 35,000 rupees a year. They are their bill is zero now, but they are additionally getting 35,000 rupees from extra power which is sold to the grid by this solar pump or the feeder pump.
This was the point, sir, I was highlighting.
Yeah.
Or discom like PDD is there, Power Development Department, they are not purchasing, they are effectively exchange of power.
Yeah.
But when we need the power requirements, they have at that time there is not available.
So I believe that somebody has to work with state discom or state electricity department on educating them on the opportunity, or some policy paper has to come in. Okay, what kind of a benefit? Looking at these are some example of different states, but first you have to understand the the electricity situation in the state and bring a case that this thing will by introducing these kind of a program in large scale, this is the benefit I'll be getting, or my farmer will be getting benefited, and this is the economy which will. So some level of education or sensitization of state level agency has to happen if it is not done so far.
So basically, the discom is not in a condition. What they are spending and what they are getting is not equal.
So this is the situation in most of the states, but somehow uh, they have to come out of this situation. Otherwise, I don't know that how much subsidy, similar number, what is referred for Jammu and Kashmir in case the electricity supply situation. But one of you have to take that role as to educate, and then of course thing will get changed. I can if some of you are PhD students in the education institution, we can produce a policy paper on this for specific to JNK, how this scheme can help in meeting some of the losses and make a state more progressive. But some background research has to happen.
Actually, this Kashmir Valley has been through so many phases.
Yeah.
One of the phase which we have been through, that was Indus Valley Treaty. When the two nations come into that treaty, we gave them 5 rivers from this place, and our country receives equal 5 rivers from other side. You must be knowing the list. Now our riparian rights on our own rivers are lost. Then we came on roads so many times. Where are our rights? We as policy makers, we keep on writing that our riparian rights in this Indus Valley Treaty we have lost these rights so many times, and we have been deprived of the water flowing through our own territory.
Yeah.
And even the country is receiving those rivers from, say, other regions.
Yeah.
They are harnessing out of it. Why this right has not been given to the rest states?
Yeah.
But that is of not being, because perhaps the government, which is leading, perhaps again coming in force, they have not come to the rescue of the poor residents like we did. We have become professionals, qualified on that under candlelights.
Yeah.
and we have read so much, and there is, I think, geopolitical issues are huge when we talk about this.
Absolutely, I agree. So I think this will happen in a over a period of time. The change, whatever you are, good or bad, whatever, it has to happen. But uh, a good research policy paper at whatever level, I don't know.
So many policy documents have reached their place, and sometimes it was given to our understanding ये तो शेर के हाथ मुंह में हाथ डालने वाली बात. We as researchers, we have done it so many times. But I believe that a consortium of researchers should stand up on this issue. And see what I will tell you one thing. Whatever electricity is going to our village or anything, whatever. So by papers, 100% of our villages are electrified.
Yes.
But we are still in these days, 2 hours electricity is there, 3 hours it's off. 2 hours electricity is again coming. There is a systematic circle. And when same thing is happening, if there is a power cut of 1 hour in Jammu, then people will come on roofs. But if we will do same, then some other will be caught in some other issues. There are some, because so many political issues are we are involved in. So we are not even talking about the rights which we actually have. And the recovery rate of peace is, I believe that it is completely 100% in discussion value.
Achha, okay. Yes. Yeah, nice.
And the percentage of the electricity which goes to agriculture, it is just 3%.
Yeah, I showed that number before you came. Yeah, I showed.
That is very horrible.
Yeah. It's only 3%. 3%. Yeah. I showed that number. I collated the number for this presentation. I saw it's only 3%. Wherever in national level it is 18%. So it's a lot of scope for increasing agriculture. So either availability is not there, or there may be other reasons also. So we don't know what is the level of this thing. So one opportunity, though the topic was given, was solar based irrigation system. But agriculture, whatever agriculture is happening, there is a crop residue which is being generated, and which can be converted into biofuels at different level. But that topic is not there today, but that is the theme I am practicing at pan India level. So, and I think many of you would like to look at that opportunity also. And it's a great opportunity which is also coming apart from solar energy. That because you all come from agriculture background, you know that better. All kind of a stubble or waste from forestry can be converted into biocoal. And because this valley has huge requirement of cooking and space heating requirement, and we have very high energy efficient cook stoves which can meet the cooking energy requirements with this local biomass, and both for space heating and also for cooking application, which has one called is tier 4 stoves. So we can demonstrate those stoves in some program, maybe on that theme, and educate people. So there is a big business opportunity in that dimension also, because India is hungry of fuels and biomass, which is otherwise get wasted, the crop residue that can be channelized for replacement of cooking energy, industry, wherever the fuel is been used. Maybe in some other lecture series, I can present you that opportunity, uh, which is turning out to be a big entrepreneurship in the country. Yeah. So this is all my from my side, and I think this is the last slide. And thank you very much. Uh, uh, uh,
Thank you, Reza sir. Now we welcome to Professor and Head Baba sir, and he will deliver a lecture in opportunities in smart solar irrigation systems. So welcome Baba sir. Now you may come. Thank you.
Yes, हेलो, हाँ अस्सलाम वालेकुम। हाँ फहद कैसे हो? आप मुझे कौन यू फोन? बढ़िया बढ़िया, आप सुनाइए। एक्चुअली मैं इंजीनियरिंग में हूँ, थोड़ा सा आई विल बी बिजी फॉर अनदर हाफ एन आवर। तो उस हाँ हाँ ठीक ठीक। हाँ गाने की और स्वास्थ्य स्कूल पर मत बोल तुम भी देखे। हाँ बोल बोल बस।
दोनों
Thank you. But be corrupt and cannot be opened. Then वापस जाऊँगा।
है।
दो जगह मैंने कॉपी